So the first part in this review that we have, let's go through and look at each different type of question and just kind of review whether or not we know how to do this. So we're looking at this, and this says 4 squared. Do you recall what that means? So that means that you are multiplying 4 times 4, right? So that's going to be, we can evaluate that as 16. Okay, so some of these are pretty standard, right? But then we get to questions that look like this: the square root of 19 and the square root of 5, or the square root of 23 and the square root of 7. So how do we estimate square roots that aren't perfect squares? So let's have a look at that. So estimating square roots that are not perfect. Okay, so let's say we've got the square root of 23. Well, what you want to think is, okay, which two perfect squares is this in between? So I know that 4 squared is equal to 16, and I know 5 squared is equal to 25. So this answer is going to lie somewhere in between. Now you want to see where it's closer to. Which one is it closer to? Is it closer to the 5 or the 4? 5? So then you're going to estimate a decimal point. And at this range, let's say it's like 4.8, 4.7, right? Because it's pretty close to the 25, but not quite there. So let's estimate that it's, and to estimate we write a squiggly equals, or you could also write an equals with a dot on top of it, which they both mean approximate. So whatever you find is easier to write. So we can write 4.8. So you could also write the equal sign with a dot on it. That's another way that you could write approximately equal to. So we're going to say it's approximately equal to 4.8. Any questions on that? You just got to pick the 2 square roots that you know and then see how in between. All right. Let's talk about exponent rules. Exponent rules. So all of the exponent rules that you've learned have to deal with exponents with the same base. So if I were to write x to the power of n, would you be able to determine which is the base and which is the exponent part of it? Yeah? Okay, so what's the exponent? The n is the exponent. And what's the base? The x is the base. All right. So what does this mean? If you were to explain to someone, let's say we have 7 to the power of 5. How would I write that out so that it would explain to someone what this means? Do you remember the term expanded form? Yeah? So what did writing this in expanded form mean? Writing it out, how many times do I have to have this 7 there? 5 times. And they're all multiplying. So it's 7 multiplying itself 5 times. Okay. So let's look at some of the rules now. So if I have 7 to the power of 5, and I wanted to multiply that with 7 to the power of 2, what would the result be in exponent rules if I were to use those shortcuts that you learned? Yeah. You would add the 2 exponents together. So you'd have 7 to the power of 5 plus 2, which is going to give you 7 to the power of 7. So that's 7 multiplying itself 7 times. So what's the general rule for this? So if I have x to the power of m times x to the power of n, then this means that it's x to the power of m plus n. And this is all in the exponent, the m plus n. You have to make sure that the bases are the same, or else you can't use these rules at all. Okay, so let's look at dividing. So if I have 7 to the power of 8 divided by 7 to the power of 3, what is the result of that going to be? Do you recall that rule? Subtract the exponents. Okay, so you have 7 to the power of 8 minus 3, which is equal to 7 to the power of 5. Now, I'm going to take you one step further. Do you know why that's the rule? There's a reason why. Okay, so let's write this out in expanded form and then look at what happens. And that'll show you why. So if I have 7 to the power of 8, oh, I chose a, I have to write this out 8 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So I've got that. And then I've got 7 times 7 times 7. Now, when we've got fractions and we've got a number over the exact same number, what does that mean? So if I have, like for instance, we've got 7 over 7, what does that equal to? 1. Okay. So now every time there's a 7 on the bottom and a 7 on the top, what do they equal? So if I have this 7 and this 7, they equal 1. Okay, so we kind of use the term canceling. You're not really canceling, you're actually reducing. You're reducing it to 1. Okay, so I've done that to one set. Now, do I have more that I could do this to? Yeah? And then? And so what am I left with here? How many 7s am I left with? 5. So that's 7 to the power of 5. So that would be your reason why. Okay, that's why that shortcut works. Okay, now I want to do one more about dividing. So let's say we have this example. 5 to the power of 6 divided by 5 to the power of 9. What is the answer to that? So same rule applies, right? But you guys have this disgruntled look on your face because what's going to happen with my exponent? It's going to be negative. Now, how come it becomes negative? Where do you have more 5s? In the denominator, right. So if I were to write this in expanded form, 5 times 5, 3, 4, 5, 6. Okay, and then how many 5s do I have here? Oh boy, too many. Okay. So you see why mathematicians develop these shortcut ways of writing things? Because it's super annoying having to write 5 9 times, right? So 5 to the power of 9 means exactly that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now what can I do here? 1, 5. I can cancel 1 for 1, right? I can reduce 1 for 1. And then what am I left with? 1 over. Okay. And then what does this give me? 1 over 5 to the power of 3. But if I were to use my exponent rules, what would my answer have been? 5 to the power of? Negative 3. So this is the relationship between a negative exponent. This is what a negative exponent actually means. It's 1 over whatever it is. Okay? So let's write a general rule for that. So what is a general rule going to look like for that one? I have to go to a new piece of paper. So I'm just going to put page 2 on the top here and February 9th. Okay, so general rule for that, if I have 1 over x to the power of n, that's the same as x to the power of negative n. So it's just the exponent that becomes negative. The whole thing, the base and the exponent, are now technically in the numerator. So it's like the reciprocal of. Have you guys seen that before? No? That's a new one for you, some of you? Okay. All right. Ooh, here. let's see if you can try this one. Let's say we have 2 over 3 to the power of negative 1. How can I write that with a positive exponent? What do you think we're going to do here? So what did this do here? What happened when I had a negative exponent? What did it do to the base and the exponent? Okay, so let's separate it and let's look at it then. I've got 2 over 1 to the power of negative 1. And then I've got 1 over 3 to the power of negative 1. So what's going to happen? Which one would be easier, this one? Do you think you know the answer to this part first? Yeah? What do you think this one's going to be? So what gets changed? It's this guy that gets changed, right? So that becomes 3 over 1. And now my exponent becomes positive. When I flip the fraction, my exponent becomes positive. So what's going to happen to the 2 now? It's going to flip, and then that exponent is going to be positive 1. Now we can just combine these two, right? So I've got 3 over 2 to the positive 1 exponent. Okay. We'll do more of those in our actual chapter when we're doing this. So don't worry too much if this one's kind of confusing you right now if you haven't seen that before. Okay. So let's have a look at an example where we've got a base. So let's say you've got 2 to the power of 3, and then that's all to the power of 5. How are we going to do that question? What's the exponent rule? You multiply the exponents together. So you take this and you go 2 to the power of 15. Now, if you were to explain me why this is, what would be your reason? Any ideas? Yeah. Okay, so so you've got this group. You have to write 2 to the power of 3 how many times? 5 times. Okay, right? So then if you count that all up, put that together, I'm way too lazy to actually write that out 15 times, but it would be, oh, you know what? Fine, I'll do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. And so if I group them in 3s, these are the groups of 3s that I had, okay? And so that's your 2 to the power of 15. Yeah? Aren't you glad there's nice little ways to write out these shortcuts here? Okay. How about if I have a question like 3x squared y to the 5, and then 7x to the power of 4, and then y squared. How would I do that question? What's the rules? Pardon me? Start within the brackets? Okay, so what is there to do in the bracket? These are all different terms, right? They're multiplying with each other. Can I add these exponents together here for the x and the y? No, why not? They're different bases, good. Okay, so there's nothing to combine in here. What I need to do is I need to look at combining my like terms. So my like terms here are my constants. These are my coefficients, actually. Coefficients. So I want to multiply them together. So 3 times 7. And then I want to combine my x's. So how can I combine my x's? And then I want to combine my y's. So how am I going to combine my y's? All right. So you want to perform those operations that are there. So that's going to be 21, and then I add these exponents, x to the power of 6 times, add those exponents together, y to the power of 7. So that's what my answer would be, and it would be multiplication in between each. So I can write it out a little closer just so that they're sitting cozier together. Okay? And the last example I'm going to do right now is when you have a bracket. Let's say we've got minus 5b over 3a, all to the power of 2. So what do you do when you have a bracket and then you have an exponent, and that exponent is containing all of this, let's say. So now this is a power, and this power applies to every single thing in this bracket, okay? So we're going to have negative 5 to the power of 2, b to the power of 2, 3 to the power of 2, and a to the power of 2. So now we can go through and evaluate and combine that stuff. So I'll work down. So this is 25b squared over 9a squared. Now, is there any way that I could reduce 25 over 9 as a fraction? No? Okay, so then you're just going to leave it this way.